All right, so let's do another example. And you might notice that I did teach 1019, and some of these examples I was getting out of that. All right, so here we have some universe of objects, and alpha in each of them is either true or false, right? And then we have some function. The function maps every guy in X to somebody in Y, right? Everybody recognize 1019 here? All right. And this was all a homework assignment one year, right? Can you do all of these? All right. So let's start with the first one. We parse it, right? And then we know we're going to have the game for each of them. And so let's guess that it's true. So give me an arbitrary function and let's see if we can go for it. Let's try to get some intuition, right? What does this say? This says alpha is true for every y, right? F is true for every y, right? And now we don't know what this function is, right? With x, for every x, f of x is some object, right? But we don't know which object, right? Yeah, but we don't need to know which f of x, which y is over here. Why? Because they're all true, right? So whatever f of x is, alpha of f of x is going to be true, right? Does that make sense? Right? So then we try to play the game, right? Right? This is saying for any x, well, f of x, I don't know what f of x, but it's going to be some y, and that y will be true. All right, so now let's play the game. She assures us of that, right? And what does this do? You give her, well, I guess I get fancier pictures here, right? You give me a Sam, she assures me that it's true, right? I give you any term, she assures you it's true, right? I give you f of x, she assures you that it's true, right? All right, so let's do it some more. Here she says she's helping you, right? So now my goal is to prove for all x. How do I prove for all x? Let x be arbitrary, right? Now I have to prove this thing, right? So how do I prove this? Well, the oracle's ready to get a y. What do I give her for y? I give her f of x, right? She assures me it's true for every y, so she can assure me it's true for f of x. And we're done, right? Everybody buy that? All right, now the formal proof, right? Somehow we prove this, right? And then from that, we can just plug in, and here's where that T ideal was, right? I know it's true for all y, so I can plug in any object whatsoever, right? And one object that I want to plug in is f of x, right? Does that make sense? And this is why proving isn't just bang, 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 right? You have to know what to plug in here, right? And then you just put now x is a free variable, and so I can plug in the for all x, right? That was pretty easy. Are people following these? Right, syntax states. All right, so another whole, when you take 2001, they do grammar and syntax, right? And I have a section of slides that covers grammar and syntax. and I haven't used them in a while because we're throwing in here things that you kind of need them, right? So it's just saying, right, why is this whole thing valid? Well, alpha is a function from terms true, false, right? And then this is a term. And so you got to know, well, what are terms? What's proper syntax for a term? It's what represents an object. And then what's a proper syntax for a Boolean, right? And I think our intuition is good enough without going too much into 2001 material, right? All right, so here's another one, right? All right, here's another one, and I guess we had some intuition to try to make it wrong. All right, so to make the whole thing wrong, we need this side false and this side true, right? So if that's false, then we right. All right, so I mean, let's read this first. Right, it says for any x, you map it over to the y, then that alpha is true, right? Does that tell us that every y is true? No, because every y might not be hit, right? All right, so that's false. So there's something over in y that's false. Poor Marilyn Monroe, she failed, right? And now here we have an f here, all right? So is it, right now, here our x is Marilyn Monroe, right? Marilyn Monroe maps over to Marilyn Monroe, right? And is Marilyn Monroe true? No, Marilyn Monroe is false, right? Everybody see that? So here it's true that is this a good counterexample? No. Well, it's a good counterexample in which this is false, right? But is this false? Right? That's also false, right? Because if you plug in Marilyn Monroe here, you get something that's false. Yeah?
You can't see your mouse. I'm not sure what you're doing.
Oh, you can't see my mouse. All right. That's funny. Oh, I see. There's two screens. I got to be over in this screen. Thanks for that. I've been mousing the whole time. You should have told me before. All right. So here we just kind of try to bang in an example and see if we can make it false, right? And what we banged over here, we made this false by having Marilyn Monroe false, right? And then we want to try to make this guy think about what we have over here, right? And over here, if you plug in if X is Marilyn Monroe, then Marilyn Monroe maps over to Marilyn Monroe, which is false, right? So that statement's false, right? All right, so did we prove that this thing is not true? No, we didn't. So how are we going to change it? Right? So let's just swap those, right? Everybody see? Now, look at, we want to prove that for every x, f of x is true, right? So you plug in all of x's into f, right? Yeah?
What's the relation sort of represented in the example here? And the other examples, it was like you had like someone loves someone else, but this is just like which person is in both boxes?
Well, the set of x's and set of y's could be disjoint the same. But here, I guess I'm making them the same.
Okay, so people map to one person.
Actually, no, we have to make them the same universe. Oh no. Here, we're only doing alphas on the y's, right? So here we're doing alpha on an f of x, which is a y, and here we're doing alpha on a y. So these don't have to be the same universe. but we apply alpha to the y's, right?
So it's just an arbitrary function.
It's an arbitrary function, right? In the other case, it worked for an arbitrary function, but now we're showing that this doesn't work for an arbitrary. We're showing this, if this is our universe, it doesn't work, right? Why? Because this side is false and doesn't have the alpha property, right? But now let's see if this is true. You give me an arbitrary x, I plug it into f, and and's not there, right? We got everybody but and. And look at everybody but and is true, right? Does that make sense? Right? So that side's true and that side's false. Right? So what would, right? So on a test, I say, is this a topology? And you think about it intuitively, you think about what it means, and you say it's not a topology, right? And then why is it not a tautology? Well, this says for every x, f of x is true. The things that you hit are true, right? Does that mean everything over y is true? Well, not if it's not hit, right? So now you have to come up with an example. Well, to make an example, you want this false. So you make and not true. And then you want to make this true. So you need everybody that's hit to be true. So you don't hit and, right? Does that make sense? Right? The problem is f doesn't hit and. All right. Everybody good? All right. So now I'm getting more 1019 on us, right? I'm going to have a new requirement that f is in the full range, right? That's we can say that somehow, right? There's injections and bijections and ontos, and do I remember always which is which? Not necessarily, right? But this is, we hit the full range, right? And then if the left side is true, if we're hitting everybody and everybody we hit is true, right? Then everybody is true, right? Everybody good with that? All right, so then luckily we don't remember all these words, we can Google them, right? So this is from the Google. And what is my statement? We have a function from x to y, and we want to say everybody is hit. You give me a y, right? Everybody is hit. So you give me a y, there's an x that hits it. Right? People see this? We want to say everybody in y is hit. So you give me a y, there's an x that hits it. All right. Right? There's, I don't know why I changed the u's and b's. All right. Thought we're going to prove that, but we're going to do some more. We're going to do some more parsing for some reason. All right. So here's a funny one to parse, right? So it parses like that, and then this one parses like that. People see that? And so now what do we have? We have two oracles, right? And that's the same as this. We have two oracles. So these two lines mean the same, right? In both cases, you have two oracles, and you prove the second thing, right? Everybody good with that? Yeah. Right. Those are equivalent, right? And it's nice to, as I said, it's nice to give them different names. All right. So this is the statement we wanted to prove before, right? That if everybody you hit is true, then everybody's true, right? But we're going to throw in here, everybody is hit. You give me some v, then there's a u that hits it, right? And why did I have U's and V's instead of X and Y's? Just not to confuse these two, right? All right, and then we want to prove this, right? Right, if F hits everybody, then this statement is true, right? All right, so we build our parse tree, and we have these two oracles, right? Everybody say we have two oracles, and we want to prove the third thing. All right, so we guess it's valid. So the oracle, the adversary gives us the function f, and gives us which guys are true. And I should be over here. Everybody good? All right, so our first oracle assures us of this. What she's assuring us, for every V, there's a U that hits you, right? And so what do we have to do? We have to prove this. How do we prove this? We have a second oracle that assures us that everybody that hits is true, right? Right, and now my goal is to prove that everybody is true, right? Are people following this? All right, now how do I prove for all y? Let y be arbitrary, right? Now I have a y, all right? And what do I want to prove? I want to prove that it's true for y. So how do I prove that it's true for y? Which oracle? The second one shows me that everybody hits true, right? So what do I need to do first? I have to prove that it's hit, right? So I go to this, this oracle says everybody that function hits is true. Oh, sorry, a wrong mouse. Thank you. Keep telling me that. All right, I'm over in this screen. All right, oracle says here, for all y, I have to prove y is true, right? This oracle shows me that everybody who hits true. This oracle says everybody's hit. So let's first, I assume we're going to first go over to, right? My first oracle says everybody's hit. And I want to say, right, says if V's over here, then V's hit. I want to know what is Y hit, right? I want to prove that Y is true. So I have to prove that Y is hit. So I go over to my first oracle and I said, first oracle, you tell me everybody's hit. Well, what about Y? Is Y hit? So I give this oracle Y for V, right? And she says, yeah, it's true for every V. Hence, it's true for your Y. Hence, I assure you that Y is hit. Yeah?
So the first oracle is showing all V, there's this U, that's showing its surjective.
Yes.
Second oracle is also showing its surjective?
No, this oracle, let's say, would you agree that a Y is hit if there's an X for which you get f of X, right? Which Y's are hits? Those which some X hits it. Let's first get my terminology. Okay, let me first define my terminology. I say Y's hit if some X maps to it.
Yeah.
Right? Now, so what do we know about this f of X? Is that it's hit. And what does this say? It says everybody who's hit, alpha is true for everybody who's hit, right?
So
it's not everybody, right? I mean, let's pause again. What this is saying, you give me an X, the thing that it hits is true for, right? Another way of saying that is everybody that's hit, alpha is true for everybody that's hit.
the whole intuition thing is that from the very outset, you know that it's true for everyone that's hit.
Yeah, yeah. Yeah, based on Well, oh, based on this oracle, everybody who's hit is true. Now over here, it says everybody's hit, right? So what does it mean to be everybody hit? I want to prove, right? I want to prove that it's true. I have a y, bad y that I want to prove it's true. So to prove it's true, I go to my first oracle to be assured that it's hit.
The second one's a weakening of the first one.
No, they say completely different things. The first one, in fact, is telling me mostly something about F, right? It doesn't mention alpha at all. And the second one is telling me the things that are hit are true under alpha. Oh, I keep going the wrong mouse. Really, let's turn this screen off.
But all alphas, everything that's through the function over alpha, is that a subset of everything first one?
This one here?
Yeah, because you're saying that for all there is everything but V is everything is V is maps to.
Yeah.
So that's all.
All of them.
So the second one's a subset. All X A and
I think they say very different things.
But it's going to be less than.
So if this is all the X's, and these are the guys they hit, right? So the first oracle says there's nobody here. Everybody's hit. And the second one says these guys are true.
Right. So
they're saying different things.
But it's a subset.
I don't know what you mean by a subset.
Just if the first one's 100 things, then the second one's in less numbers.
These guys, this is a subset of this.
Yeah.
Oh yeah. Yeah.
I mean, what's the second one called?
The second one says this subset is true. Right.
It is a subset of the first one.
No, the first one doesn't talk about. First one says that this set equals this set. Yeah. Right. I mean, if I want to prove that it's Y is true, I first say, this guy says me, Y is true if it's hit. Well, this one tells me Y is hit. Right. So I come over to this one and I want to say, how do I know that it's hit? Well, if I give it Y, it gives me the X. All right. So it's showing me that there exists a U. So I say, give me that U. Right. I know I tell her Y, she tells me a U that hits it. Right. So now I know that U of F of U is Y. Right. Then I go over, right. So I know F of U. Right, then I go over here to the other oracle. Right, now I go to oracle 2, and I give, now oracle 2 is saying for every X, right? So now I give oracle 2 an X. What X do I give? I give U, right? I plug in U, and she assures me that it's true for my U. So she says alpha of F of U is true, right?
So the thing don't like blocking this.
It's, oh, here I thought it was blocking my, yeah, exactly. I hate it. Go away, go away.
There's a small arrow at the bottom of the box. Small. Okay.
That one?
Center of the big box.
Oh, this one. All right, go away. So many technical problems, right? I'm getting to be an old man. Don't give me so many technical problems. All right, let's go back. Are people following this? It gets more convoluted, right? So here, right? So what do? We were given a Y. We gave the Y over here, who gave me an X, such that F of X gives me my Y. And that X was this U, right? And then I give u over here, and she assures me that alpha of f of u is true, right? Well, that f of u is y, so alpha is true for y, right? And that's done. Okay, was that scarier? It's a little scarier, right? So what? So on an assignment, you could probably do in a day. You could probably do that. Could you do it in 20 minutes? You probably couldn't do it in 20 minutes, right? There's too much thinking, right? And you must admit, you go back to test one, the examples you didn't. I think I give you examples where you don't have to think very much if you just crank it out, right? This example required a lot more thinking and intuition, right? All right, so can we do a formal proof here, right? So left side, right side, right? So that gives us, this is the left side, that's the right side, right? And then this left side, right side, right? So we have, here we have our two oracles, right? To give us what we want, right? And then we need to do a for all x. So here I'm kind of going backwards, right? You know, the other proofs, I went forwards and you kind of had to know where you were going. I probably should have gone backwards. So here I'm going backwards. I say, how do I get a for all y? Well, I go backwards. Now that y is an arbitrary y, right? This is like saying the adversary gave me a y, and I have to prove it's true for that y, right? Here, this is a specific y, and this is a local variable y, right? People see that? Now my goal is to prove alpha is true for y. All right, great. So now how do I prove alpha is true for y? Well, it's a little convoluted, but what I need to prove is that f, right here we got, right here I have an f of x, right? So we need to prove that f of x is y, right? If we prove that there's some x, that gives me y. This is saying I need to prove that y is hit, right? So here I'm saying y is hit by x, right? Well, if y is hit by x, then here I have a for all x, right? So it's a for all. I can plug anything I want into this x, right? So who do I plug into this x? I plug in this exists x, right? So, so that's what I kind of did to go from here to here. Oh, here. I wanted to prove f of y is true. I didn't quite see this. So we're proving that f of some x is true, where f of x equals y, right? And then now this gives me what I need, right? Everybody see that? Right? You see all these lines follow. All right. So now I have to do, I have this and I need to get this. Right. So how do I do that? Well, this is a for all u, for all v. So when I rip out the for all, I can plug in anything I want. Well, we're trying to get a y here, right? So that's where you have to not just be blindly ripping off for all v's and putting a v here. We have to plug in the y, right? So everybody see I ripped off the for all v and replaced it with the y. And then I say, oh, there exists a u. Who is that u? Anybody know why I have a little space here? It's because I have an x, but the x depends on the y, right? So it is true. This makes sense anyway, right? If you read this, I remember, unlike George, I wanted every line here to mean something. And if I read this line, what I say, Y is a free variable. So for every Y, what? For every Y, there is some X that depends on my Y, right? For every Y, there is X. Right? So this means the same as that. Right? And so then, is the proof still go through? Does it mind that the X changes? You have to check. Does it mind? And it doesn't mind. Right? Everybody see that? You got this proof? Yeah.
So, just wondering, since slides have a lot of animations.
Yeah.
So, as long as we write the correct answer in the test we have,
Yeah.
that's accepted. Whether if the style is a little bit.
Yeah. So, what would be a perfect formal answer is everything. You take a, in fact, let's hit the next button. There. That's the perfect answer, right? The TA is just going to make sure there's a big gap in life between if I have a proof, can I check line by line that every line is followed by a legal rule? And that's what the TA will do. Now, how do you come up with the proof? Right? My belief is that if I gave you this proof and said, look at line by line, it works, you would not learn how to come up with a proof yourself. Right? So I'm trying to teach you how to come up with your own proof. Right? It's a how-to. Right? If I was teaching the TA, I would just give them this and say, look at line by line. TA's job is easier than your job. All right, I assume we're done. So we'll do more of these next class.